On to the final question. A program uses a linear queue to store up to 100 integers. A 1D array queue is used to store the data. The head pointer points to the first number stored in the queue, and the tail pointer points to the next free space in the queue. Write program code. So a queue question. So confusing, I thought this first question about priorities was a queue question. It ended up just being a sort of array-based question with an insertion sort. Let's make a new file, question3.py. And let's declare a global array queue. It's an array of integers. Yeah, 100 integers. So 0 to 99 of integer. So queue is, what will the values be? Let's use a non-type for in range 100. Let's declare our. So sometimes you might see 0 being used for the default value of an integer, but it depends if 0 can represent something. Let's leave it as 0, I think, because I think what we'll find is that the things going into the queue are probably non-zero numbers. Okay, declare the global variable head pointer. An appropriate initial value for the head pointer should be 0, and an appropriate initial value for the tail pointer should be also 0. So when we have a queue, let's say our queue looks like this, and we've got some free spaces right now. What's happening right now is we've got the head pointer being the front of the queue, and because there is no one in the queue, both the front and the back of the queue are at the same position, which is just position 0. So that should be our evidence for 3a. Let's put that in. Let's write a function called enqueue, and what enqueue should do. Let's put this in the main method, in fact. If name is equal to name, then we're going to define a new function called enqueue, which takes an integer value and stores it in the queue. Let's call it new value. It's coming into the function as an integer. And it then needs to store some things in the queue. Returns true if the value was stored successfully and false otherwise. So we need to think what happens when you because we're asked to write a function, we probably need to return some values, right? So we are going to need to return we don't have to return the array, but let's put that in there anyway. And when we're adding something to the queue, what changes is the tail pointer, and that's an integer. So our function enqueue will take an integer and return a list and an integer, or an array and an integer. Oh, no, sorry, it won't. It needs to return a Boolean flag. But how else are we going to... Oh, these are global. Ignore me, I'm telling you the wrong thing. What we need to do is return a Boolean, and that's because all of the other data is global. That makes it a bit easier. So how does a queue work? Then we need to check, first of all, if the queue is full. And what makes a queue full? A queue has no space if every item is occupied. So we could say something like, if the head pointer is equal to the tail pointer, then the queue is either empty or full, which is why we would normally use a third variable to keep track of that, like a queue full variable. But let's say something like, and the head pointer is not equal to 0. So if we have something other than, but I guess then we could also have the queue. We could be in a position where we remove everything from the queue and both could be empty, overlap at the same point. And this is why I don't think that having 0 as an initial value is perhaps the best idea. Let me change the implementation and we'll check the mark scheme at the end. What I think we should do is have the head pointer and the tail pointer set to null. And then when we add something to the queue, we can say like, if the head pointer is null, then the head pointer now becomes 0. Otherwise, if the head pointer is equal to the tail pointer, that's when we return false because it won't fit in the queue. But otherwise, we just say in the queue at the head pointer, although we should be using the tail pointer, shouldn't we? Let's think about this. Tail pointer is none. Tail pointer is now 0. Okay, maybe I take it back. Maybe we do need to use 0. Let's do it the other way. Let's have another variable that keeps track of the size of the queue. Queue length, which starts at 0. And to check if the queue is full, we will need to say if queue length is equal to 100, then we return false. That's because there won't be any more free space. Otherwise, what will happen is we can add something to the queue. And where do we add something to the queue? So if the queue starts with a tail pointer of 0, what we'll say is take the queue at the tail pointer and add in the next item, add in the new item. And then all we need to do is increment the tail pointer by 1. What's best then is, because we might have the situation where the tail pointer has reached the end of the array, but because we've been dequeuing things, there is actually some free space at the start of the array, for example, in this circumstance. So what we want to make sure is if we increment the tail pointer past the end of the array, we need to wrap back round to the beginning, and this is kind of like a circular queue. So let's just put that in. I'm not sure if it's required because we don't see the term circular queue, but let's just put it in anyway. It wouldn't hurt. If the tail pointer goes beyond 99, which is the maximum index, let's put tail pointer back to 0. And that should be a working enqueue function. So let's see if we can code the main program to enqueue the numbers 1 to 20 inclusive. Let's write a Python for loop to do that for each number in the range of 1 to 21, because Python is exclusive of the upper bound. Let's check if enqueuing is successful. So if we can enqueue and it returns true, then we can print the message successful. Otherwise, we need to print the message unsuccessful. What are they testing here? They're kind of checking your understanding of how to write modular code. We've got a function returning a value, but they're asking you to print inside the main program, not inside the function. So let's see if it works. Python question3.py. And it was always unsuccessful. Why is that? Because we forgot to return true after in the else clause. Let's try that again. Okay, that's what we should expect, like 20 successful messages. So yeah, they didn't specify the use of this queue length variable, but if we have a head pointer and a tail pointer starting at 0, I'm not certain of the way that you check when the queue is full, unless you use something like, yeah, you need null values. So yeah, from what we've seen in older mark schemes, there's an extra variable called queue length that helps you to work that out. We'll check the mark scheme at the end and see if they agree. The following iterative pseudocode function calculates. Oh, hold on a second. Let's just put the evidence in. So B was the enqueue function, and C was the main method. The following iterative pseudocode function calculates the total of all the values in the queue. So we've got an iterative function, and it wants us to rewrite this function as a recursive function. So how should a recursive function work? Well, what is it doing at the moment? We're looping from the start up to the head pointer. And each time we're adding on the value in the queue to the total. Why are we looping up to the head pointer? Is the head pointer not the front of the queue? I guess we start from the back of the queue, so start perhaps is passed in to as a certain point. So we need to go backwards from the end to the front of the queue. But why is that going down each time? Start -1 to head pointer. I guess because that, okay, we do need to go down. So let's rewrite it as a recursive function. So recursive output. We need to know where we started from, which will be an integer. We need to know the current total, which will be an integer. And it needs to return an integer, which will be the total. So we need to think, rather than using a loop and then going to the next one, we're going to use the start each time. And we're going to say, wherever the start is, that's what should be added to the total. And then we need to do the same thing again, but we just need to take away 1 from the start. So we want to recurse the function with the 1 before the start, passing in the total. And that's what we need to return. But that's only the general case. That's when the recursion happens. If we want to have some point at which this stops, we need to say, okay, if some base case, then that's the point where we just return the total and we stop recursing. So we need to now consider what is the base case. So we've got to a situation where we've start is less than the head pointer because we've gone below the head pointer. That's when we can return. Otherwise, we add the current one. Unless, what might make more sense if we say equals the head pointer, and let's always add the total. Because it's inclusive, we go from start -1. Why do we subtract -1 from start? That doesn't make any sense. So the first number added will be 1 less than the start. We've got no idea why they would want you to -1 straight away. What's the point in passing in a value and then just finding? Okay, let's test it. Let's see if it works anyway. A bit of a weird question. So let's call the recursive function and output it. Print recursive output. See what happens. So we need to pass in two values. The main program calls the recursive function from part 3D and outputs the value returned. What are you wanting us to put as this parameter though? How bizarre. Let's pass in the tail pointer anyway. I assume that's the, even though tail pointer is a global variable, it seems very weird to me, but let's pass in the tail pointer. And we probably need to pass in a value for total as well, so the total will start at 0. And the total return was 220. So what we should have is all of the numbers from 1 to 20. So let's see if I can just get Python up. 1 plus 2 plus 3 plus 4 plus 5. So it's returning the correct value because the sum of the queue's values is 220. Let's just check if the algorithm matches. I'm really not sure why this -1 is there. What that is telling me is that their implementation of the queue is different because the tail pointer is not pointing to the last thing in the queue. It's pointing to the next available space. I think that's what that is suggesting. So the head pointer should start at -1, and the tail pointer, in fact, starts at 0. I can sort of see here that they're using the tail pointer to point to slightly different implementation. So what that means is that we don't need to increment the tail pointer. Oh, no, sorry. No, that is correct. The tail pointer is always one more than what's populated. So when you start, you do start from -1. The issue is that because we initialize the queue to have 0, it is just doing 0 for us. So how can we fix that? We need to say if start will that work? Okay, I think that works. All right, let's put that in. So 3D is the recursive function, 3e1 is the main method, and 3e2 is the tests. So let's spend some time now, like just cross-referencing this with the mark scheme. I've got the official mark scheme for this paper just here, and I'm particularly interested in this last question. Interesting, they're not specifying, so they are telling you to do the -1 here, which doesn't really match the iterative function, seeing as in the iterative function, the -1 happens inside the function. That doesn't make sense to me, but okay. So could have just done -1 here and then not had to do the -1 inside the scope of the function. I'm sure either approach would achieve the mark. 210 was the right answer, and the recursive function so it has to return the final total, which we did, and it has to recursive call with start -1, which we did, adding return value to a total, or adding value in queue before the recursive call, which we did. So whilst their implementation kind of differs, I think this would still achieve the marks. Let's see the one before. This is correct. And let's look at our enqueue implementation. So if the head pointer is -1, oh, that's something that we forgot. So they are expecting you to initialize the head pointer to -1. So the tail points to the next free space, whereas the head pointer should be null. So what this is not using a circular queue, which kind of changes the implementation a bit. So this bit doesn't seem to be needed. You're not expected to use a circular queue for this question. And what that means is because there is no circular queue implementation, the only time when the 2 pointers are equal is when the queue... Oh no, you don't even need to consider that. So this kind of queue doesn't make sense to me, because every time you dequeue from it, you're essentially then wasting all of the space that came before the position. So that can never be used again, which doesn't seem to make sense. But this is the linear queue. Yeah, the linear queue doesn't require the wrapping around. So we've put too much in here. There wasn't really a requirement to use the queue length then. Let's just check some of the other questions. It seems okay. So it's important to do strip. Let's have a look. I'm interested in their insertion sort implementation from question 1. That's pretty similar to what we did. Oh yeah, and interestingly, they do sort of model the splitting up the values, because they don't really ever show like copying an array into another array variable. Good, starting at the second position. Okay, that's pretty much it. A little bit of uncertainty there with the final question, which is using a queue. So I guess if they don't ask you to use a circular queue, then you just need to make a linear queue instead. I hope you found this helpful.